In this video, we're going to look at how the law of sines is used to find missing angles or missing sides in triangles that are not specifically right triangles. So up at the top of the page, I have the law of sines, and what it's saying is we have this relationship between a side and the angle across from it. So A divided by the sine of its opposite angle A should be equal to B divided by the sine of its opposite angle, which is also equal to C divided by the sine of its opposite angle. So when you write those three ratios, A over the sine of A, B over the sine of B, C over the sine of C, they're all equal. And we can set those up and then use them to solve for the missing number in a proportion. So let's take that idea and look at our first example. The first thing I see is that I have two numbers that I know. The side of 20, written as a ratio over the sine of the angle 47, which is opposite that. Again, they should be opposites. That should equal this side 25, written as a ratio over the sine of its opposite angle. But that's the angle that I want to know. So I just have to solve this proportion and figure out what is x. So we start by cross multiplying. 25 will multiply by the sine of 47, and that should equal 20 times the sine of x. Now remember, sine of 47 and sine of x represent numbers, a ratio, some sort of decimal. So I like to put parentheses around that to remind myself that that whole thing is one number. So to solve this for x and get x by itself, the next thing I need to do is divide both sides by 20, because that will give me just the sine of x on the right-hand side. And over here, I have this big long expression, 25 times the sine of 47 divided by 20. I'm going to go ahead and type that into my calculator, 25 times the sine of 47, and then divided by 20. And I'm getting 0.914192. I'm going to write at least a few numbers here. I don't want to round. I'm leaving that on my calculator. But the reason I'm punching it out is, remember, you can't take the sine inverse of anything bigger than 1. And my next step is to ask, what is the angle, or in other words, what is the sine inverse of that ratio 0.91419, because that should be the angle x. So I've left that on my calculator unrounded, and now I'm going to hit sine inverse, and it's telling me that that angle x is equal to about 66.09, which we're just going to round to the nearest degree, 66 degrees. So you notice, compared to the first example in this lesson, I didn't have to draw an altitude and do sine twice. This law of sines relationship exists in every triangle ever, and I can just go straight to that and then solve the proportion. Let's look at example number 2. In example number 2, again, I'm looking for these relationships of numbers that are across from each other. So right away I see that I have 10 across from an angle of 42. So that means that side of 10 over the sine of 42 should equal, and since I'm looking for x, I need to know that opposite angle. Well, I don't know that one, but I could figure it out, because 67 plus 42 is a total of 109 degrees. 180 degrees minus 109 already taken up leaves me 71 degrees total in that triangle. So I'm using the idea that there's 180 degrees in that triangle. So there's my relationship. I have the side x over the sine of its opposite angle, 71. And again, I'm going to solve this just like any other proportion by cross multiplying. So I get 10 times the sine of 71 should equal x times the sine of 42. Again, I like to put the parentheses around this to remind myself that that's one whole number, but I'm not rounding it yet. And what I see I need to do here is just one simple division. I need to divide the right-hand side by sine of 42 to get x completely by itself. So what I'm typing into my calculator is 10 times the sine of 71 divided by the sine of 42. And I haven't rounded anything, so when I type all this in, then I will round it. So 10 times the sine of 71 divided by the sine of 42. And I get 14.13. And since it's a side, I'll go ahead and round it to 2 decimal places. So the length of that side of that triangle has to be 14.13 with these angles on that triangle. Let's do one more where you have to find the missing angle. Again, to use law of sines, we look for an opposite side and its opposite angle that we know. So in this case, I know that I have a 22 over the sine of 80, its opposite angle, should be equal to the 14 over the sine of its opposite angle, which in this case, the angle x is what I'm looking for. So now that I've used the law of sines to set up my proportion, I'm going to solve it just like I do any proportion. I'm going to cross multiply, so I get 22 times the sine of x is equal to 14 times the sine of 80. In this case, I need to divide both sides by 22 to get that variable x by itself. So on the left-hand side of the equation, I'm left with the sine of x is equal to 14 times the sine of 80 divided by 22. Here again is where I like to type all that in. So 14 multiplied by the sine of 80 and then divided by 22, and I'm getting 0.626695 equals that sine of x. Now again, I'm not rounding this off my calculator, but I'm checking to see if that number is less than 1, because when I want to know the angle x, that's when I type into my calculator sine inverse of that ratio, 0.626695, and when I do the sine inverse of that, I end up getting 38.8, or roughly a 39-degree angle. So in this case, x has to be 39 degrees. And that's how we're going to use the law of sines to find missing sides and missing angles. Make sure you do the practice problems in your workbook on the following pages and see me if you have any questions. Good luck.